Welcome everyone who may be tuning in now. Thank you for joining us for this panel, Testing Infrastructure Across the United States. My name is Matt Sanders. I'm the Program Director for the Pacific Ocean Energy Trust. If you haven't heard already from Jason's introductions, I've been with POET for about 10 years now, and I'm currently leading the Teamer program within POET, among some other things as well. Anyone who has joined us in years past may recognize my backgrounds here. We miss seeing all you in person this year in Portland, but certainly happy that you all can be here virtually with us today. And I'm really happy to have such a great panel to help us talk through testing infrastructure in the US, with the caveat that there's a lot more infrastructure than represented on this panel. There's a lot of great institutions and facilities across the country that we would love to put more focus on. But that's a big part of the Teamer program, and I'm happy to talk about that for a little bit. And then we'll go through and I'll let each panelist introduce themselves when we get to their part of the presentation. But for now, I'm going to go ahead and start by providing you all with just a bit of a background on the Teamer program and what POET's doing with the testing infrastructure across the US and how we can provide assistance to technology developers and researchers. So Teamer stands for Testing Expertise and Access for Marine Energy Research. It's a program that we've been running with support of the Department of Energy since the end of 2019. We offered our first round of technical support in mid-2020. I think I got that right. And we just closed applications for our fourth round just last week. So I'll talk a little bit more about the successes of the program to date as we get a little further here. But in a nutshell, I don't want to spend the whole time talking about Teamer. I certainly could. The goal of Teamer is essentially to provide access to testing infrastructure by providing a wide range of facilities to accelerate integration and physical testing and validation into technology design, as well as providing access to world-class expertise by pairing technology developers with the nation's leading marine energy experts. As you can see from that map over on the right-hand side of your screen, we have a vast network of facilities across the country that are able to provide support to technology developers at little to no cost, short of some different rules with what the developer needs to provide for the testing. But the goal is of Teamer to provide current, quick, and efficient access to testing facilities to test your current technical objectives. As identified as a barrier to entry in the market, that technologies, models, validations were difficult to come by. Funding was difficult to access, and accessibility to these facilities is a challenge for early technologies and even late stage technologies. So the Department of Energy has graciously worked with POET to establish the Teamer program and provide access to these facilities. There's obviously more information on our website, teamer-us.org. And then we're always happy to chat with developers and facilities who may be interested in joining the network as well. A little bit more about the network itself. We're happy to have more than 100 different capabilities across at least 33 different organizations across the country. We've worked really hard in the early stages of the program to identify testing and expertise facilities across the nation, and then we've worked with them to bring them into the program and to provide, hopefully providing them with the opportunity to give that testing to the industry as needed. We do offer requests for technical support, often referred to as RFTSs, currently offering them every 3 months, and the program is currently slated to go through 2024. To date, this doesn't include the last round that we've just closed. We're supporting 53 different RFTSs, and that's at something like 20 different facilities across the country. And then in this last round, we received 17 applications, which we're going to start reviewing and reaching out to those folks to move them through the process as well. Teamer funding is available to any technology developer or researcher, regardless of their country of origin. However, due to the nature of the funding, all the testing expertise has to occur in the United States, which we're more than happy to provide. There's a lot of great expertise, as you're going to see on this panel today, to support the industry here in the US. We are very excited to start offering open water testing in Temur. This is something that's been a long time in the making. It's a challenge. It's been a challenge, but we've had some great folks that we've worked with, especially on this panel, to help us navigate the waters, actually, and how we authorize and can support open water testing within Temur. How are, the silos that we're really going to offer testing through will come in two ways. One will be testing through open water test facilities, and these are places that have somewhat pre-approved infrastructure to accommodate different types of marine energy testing. We recommend and require that any developers looking to test at any of these facilities consult with the facility themselves prior to applying for support. This is really to ensure that their technical objectives can, one, be met by the facility, but also, especially with open water testing, that they fall within the pre-approved kind of opportunities that are identified at those facilities. It has a lot to do with environmental considerations, but we've worked with these facilities. We look to work with a lot more facilities in the future. A lot more info to come on that. But we think it's going to be a great opportunity. We're really excited to see it moving forward. There's been a lot of requests for it as well. And then the other kind of silo that we'll be working in is what we're calling open water capabilities. And this can go a lot further than this conversation, but essentially utilizing instrumentation and support to add value to marine energy testing outside of a pre-approved facility. So examples may be resource characterization at different sites, or putting hydrophones in the water around a deployed device to get some measurements there. The facility is going to continue to grow. The network is going to continue to grow. We're going to offer a lot more capabilities over the future. We really think this is a great opportunity to highlight the expertise at the facilities to provide additional data to your open water tests, as well as for the developers to learn more about their technologies once they're in the water in that real environment. This is all coming. I think the email's drafted. We're ready to hit send, hopefully on or around October 1st. And then with anything open water related, on big asterisks there and small type, certain restrictions will apply. So we look forward to working with the industry to navigate this process. We expect there to be some questions and some things that potentially haven't been fully identified, but we have a great team that we're working with, and we're really excited to move that forward next month. So with that, I'm going to take one last second here to relay a message that was sent to me by one of our facilities at Sandia National Labs, and my screen is blocked. Let me see if I can move that. This is from Sandia. They asked if we could put this text up there and let anyone watching this know that as part of a WPTO funded project, Power Takeoff and Mooring Line Reliability Testing Facility, Sandia National Labs is requesting input from developers and researchers to better understanding the reliability testing needs around PTO and mooring lines, as well as umbilical cables for marine energy applications. As part of this project, Sandia plans to develop a facility in 2022 that enables short and long-term testing to understand the mechanical properties and technical limitations of rope belts and cables used for marine energy applications. Please contact Budi Gunawan to discuss your specific testing needs and fill in a short questionnaire. That link, if anyone's trying to click on it now, I've done that before in Zoom meetings, you probably can't. We'll be posting that in the chat as well. But if you want to take one more second here to write down Budi's email address, or as always, feel free to reach out to Poet. We're happy to connect you in the meantime there. So that's my spiel. I'm going to turn it over to the experts here to let them talk about the different testing infrastructures that they work in. As I mentioned earlier, this is just a brief glance at the large infrastructure across the country. We're really happy to have Nikki and Dan and Bryson with us today to talk about their facilities. So Nikki, I'll let you take it away.
Thanks, Matt. Let's see. All right. Can you see the slide?
Looks great, Nikki.
Yeah, you got it? Okay. You can hear me okay?
Perfect.
All right. Let me just move some things around here. All right, so I'm Nikki Sather. I'm here today to talk about PNNL's Marine and Coastal Research Laboratory. Today I'm going to share a little bit about kind of our general capabilities, some information about who we are, where we are, and then I'm going to transition into some specifics on our teams and our projects that are relevant to marine energy testing. So I work at the Marine and Coastal Research Laboratory. We're in Swim, Washington. Our facility bears the ear-catching acronym of MACREL. You'll hear me refer to that several times. We are a satellite campus of PNNL, whose main campuses are in Richland, Washington. We've been operating as a marine lab since around the late 1960s. Our research focus has evolved a bit since that time, and today we are working on developing and deploying coastal science and engineering capabilities that are relevant to energy, the environment, as well as national security. And integral to our successes really are the collaborations that we foster. So those include industry partners, academic institutions, as well as state, federal, and tribal organizations. So our facility sits at the entrance of Swim Bay, which is adjacent to the Strait of Juan de Fuca. So this is the water body that separates the North Olympic Peninsula on Washington State from Vancouver Island in Canada. We are in a readily accessible location. We're about 2 hours west of Seattle via car and, if you choose, ferry ride. Our facility sits on 140 acres, and of which includes 65 acres of tidelands. And so you can see in this inlet here, down at the bottom, this purple polygon shows our tideland coverage. Within the next year or so, we expect that DOE is going to purchase a lot of acreage here, about 117 acres, including the tidelands. And so that means the facility will be transitioning to a federally owned facility. Our campus is made up of two different areas. So the upland area sits on a bluff. This is about 100 feet above sea level. The shoreline facilities are built adjacent to the beach. And so many of the facilities along the shoreline are relevant to supporting the marine energy testing that we do. You will see in this infograph that we really consider the adjacent water body, this 5,000 acres in Swim Bay, as part of our research platform. So we certainly do what we can to maximize this as a research space. In terms of our staff, our numbers grow and contract, and that's certainly true in spring and summer when we see a heavy influx of students and visiting scientists. But on average, we have about 80 researchers on campus. We are a technically diverse group of folks, so our scientists include biologists, ecologists, engineers, chemists. We have a number of indoor and outdoor capabilities that support our testing and experimentation. So our pier and our floating dock provide access to our vessels, but they also provide a platform for deployments that require data cables and other power needs. Our wet labs provide access to either freshwater or seawater that can be flow through or filtered. So this is particularly relevant to things like biofouling and biocorrosion testing, scaled prototype testing, as well as component testing. We use our dry lab spaces to support activities related to the design, test, and build of components, sensors, platforms. Our Arctic lab can be retrofitted to perform seawater tank testing under freezing conditions. And I'll kind of share a few examples of that later on in the slide deck. And then lastly, we have a number of tanks of various sizes outside that offer opportunities for mesocosm experimentation. We are in the process of adding several new capabilities to MACREL that I wanted to share with you today. So we have plans to install a cabled array that will support deployment of equipment and devices that require underwater power, as well as data connection. So you can see this illustration on the slide here of the cabled array. It's going to be located close to our facility, which offers some inherent convenience. But in addition to that, the location can accommodate opportunities for testing either in high current or not, depending on what the research needs are. The marine energy battery storage system is being designed. It'll be located on our shoreline facility, and it will be designed to connect devices via that cabled array. And so you might think an example of that could be a turbine. However, the battery can also be tested independent of power generation. So this would mean various simulations and modeling. And then lastly here, we have this autonomous surface vehicle. So the rendition that you can see here on the slide, it's going to be designed as a testbed for autonomy, as well as a proxy for marine transportation. So testing of docking and charging capabilities, for example. Our dive team is made up of scientists. So this means that not only do they understand the technical aspects of diving, they have a deep appreciation for what it means to perform experiments and collect high quality data underwater. Of their many skills, I love that we highlight their ability to be cooperative research targets. So this means that, on request, they will pretend to be seals underwater, if you ask nicely. But really from a technical perspective, what this really means is that some of our divers are trained to use rebreathers. So this means they emit fewer bubbles underwater, and they can and have in the past served as underwater targets for different sensing technologies. We have a number of vessels that support our in-water work. So this means that we can match our testing needs to the vessel capabilities. We are excited that within about a year from now, we expect to be welcoming a new member to the fleet. So this will include a much larger vessel, similar to the picture that you see on the upper right here. The larger vessel will bolster our ability to support a greater range of marine energy testing needs. So this image right here shows the mouth of Swim Bay. So we refer to it as the channel. Our lab is along the shoreline to the right. You can see Travis Spit is the sand feature on the left. Water depths in the channel range about 12 meters. In the bay, they're 32. And then as you move north out of Swim Bay, depths increase rapidly in the Strait of Wanapauga. So these images depict the normalized velocity fields in Swim Bay. So the image on the left is velocity during flood tide. The image on the right are velocities during ebb tide. So blue is slow, red is fast. Velocities can range anywhere from 0.5 meter per second to 2 meters per second, with obviously instantaneous velocities being much higher. You can see though from these images that the location, the extent, and then the intensity can change depending on which tidal cycle you're in. But there are some areas that are pretty consistent. So that's an example of that is southeast of our dock. So these data are useful to us because they help us design experiments and plan deployments. It means that we can be dynamic in terms of how we deploy things depending on testing needs. So I would be remiss if I did not talk about permitting. We have 2 pre-permitted areas, one in Swim Bay and one in Clallam Bay, which is to the west of us. So the benefit of having these 2 sites that have federal authorizations and supporting permits is that it allows us to conduct a number of pre-approved activities with very little lead time. So this doesn't mean that anything goes. What it means is that we have a general envelope of things that we are allowed to do. And so when projects come in the door, we do some careful comparison of scope to what those envelopes are. We make sure that everything is aligned. And once we've done this internal verification, we can move forward with testing. All right, I'm going to move on now and share a few details of our teams and our projects that are relevant to marine energy testing. My hope is to adequately amplify this research, but I think that you're going to recognize that each one of these slides really could be a talk in and of itself. So I've included some list of names as POCs. If you're interested at a later date for more details, please follow up. So our coastal modeling group supports marine energy testing and evaluation. So certainly wave and tidal resource characterization and assessment are a key focus area. Other applications of these capabilities include evaluating risks and uncertainty. So an example of this could be, coupling of hydrodynamic models with underwater acoustics to help with siting and permitting of devices. In the PVE space, these high resolution data sets are relevant to coastal communities and coastal resilience. So think hazard assessments, for example. So this slide depicts a scaled approach used to analyze integration and device level modeling. So this work is led by our distributed systems team who perform this modeling at various scales, which is what you see here. So kind of moving from top to bottom. Applications include understanding how to balance integration requirements, how to handle local integration and interconnection issues that might arise. And then finally, at the small scale, we have modeling for device prototyping and device analysis. PNNL leads the Ocean Energy Systems Environmental Program, which is built on collaboration with 16 nations under the IEA Ocean Energy Systems. I'm sure many of you are familiar with this work. This team brings together experts to disseminate critical information to the industry as well as regulators. They use a variety of approaches. Some aspects of their work include workshops, forums that bring together experts. I believe there's one being held tomorrow as part of this conference. And of course, there's the State of the Science report, which has been released every 4 years since 2012. Triton is the DOE initiative that's designed to support environmental monitoring technologies. So ultimately, the goal of this work is aimed at helping reduce barriers for marine energy deployment. This team is busy. They've been incredibly busy this summer, out and about doing field testing. They're focused on developing deployment methodologies for marine energy applications. They offer a range of expertise in testing and deployment in open water, including at marine energy test sites. So Matt talked about TEAMR earlier. PNNL is supporting TEAMR program through a couple of different means. We perform modeling and desktop analyses, bench testing, tank testing, and we are looking forward to open water testing that will soon be added. So currently we are working with developers to do things like understand environmental compliance needs relative to specific device types. We have another project that's focused on characterizing tidal energy resources in the San Juans. That's a collaboration with the University of Washington. In another project, we are providing expertise to integrate software and hardware configurations for a state-of-the-art drifting hydrophone. And then lastly, we have 2 biofouling tests that are geared towards understanding the effectiveness of devices and components of systems. So those are being run in our flow-through seawater tanks. So I wanted to close with some examples of additional marine energy relevant tests that have occurred at Mackerel as of late. So these capture our in-water research activities as well as our tank testing. In support of resource characterization work, we recently ran an experiment to evaluate the potential interference of 2 different ADCP systems that were running at the same frequency and within close proximity, and that work was done here in Swim Bay. In our Arctic lab, we have conducted an experiment that was focused on evaluating the effectiveness of different lithium-ion batteries in freezing conditions. So we were interested in determining if wave energy is a more effective way at charging batteries than solar in ocean-based observing platforms in cold climates. And so we combined this lab experimentation with simulations to evaluate the effectiveness of wave charging. We also conducted an experiment of polycrystalline diamond bearings as an alternative to steel bearings on marine energy converters. Again, we used our Arctic lab to perform this test, and you can see an image from that experiment up on the right here. So that is an ice slurry in the tank. Things were fully functional above that first layer of ice. So that test is wrapped up, the first phase, and is moving towards phase 2 of testing. In support of the Splash contest for the Ocean Observing Prize, we recently installed a wave measurement buoy at Clallam Bay. We're looking forward to the data that is going to be collected there. And then finally, we have used JSAX tags, which is an acoustic tag technology developed at PNNL to track sablefish movement in Swim Bay. So the 3D tracking work was done in support of efforts to develop approaches at reducing uncertainty regarding fine-scale movement of fish in and around turbines. So with that, I will wrap it up and say thank you. Thanks to Matt for having us here today, and maybe turn it on over to, I think, Bryson's next.
Yeah, thank you, Nikki. That was fantastic. Thanks to PNNL for all your support in TEAMR and just to the industry at large. Certainly a valuable asset to the group. So with that, I am happy to hand it straight over to Bryson. If anyone has any questions for Nikki, feel free to post them in the chat or the Q&A. either on Huva or in Zoom. We're seeing them all. So feel free to start dropping those questions in there. Bryson.
Great. Just confirming you can hear me and you can see the correct slide deck and not my presenter view.
Looks great, Bryson. Thanks.
Well, fantastic. And I'm delighted to be here. Thanks to the POET team for giving us this opportunity to sort of reconvene and get together and have these sorts of discussions. So I'm here to talk about testing facilities and expertise under the sort of Pmac umbrella at the NIMREC and what we sort of try and offer. So to sort of just to get everyone on the same page, what is Pmac, the Pacific Marine Energy Center? Pmac is a collaboration between Oregon State University, the University of Washington, and the University of Alaska Fairbanks. And we all sort of collaborate to help facilitate the marine energy technology commercialization, to inform policy and regulation, and to educate the workforce of tomorrow. So the goal is to serve as an authoritative, neutral voice regarding opportunities, capabilities, and effects of marine energy. So that's sort of broadly where we come from. Now, Matt asked me to give a 10-minute overview of all of our testing facilities, expertise, projects, and how they relate to TMER. And while I greatly appreciate this opportunity, I'm also equally aware this is sort of an exercise in exclusion. I'm going to forget somebody, and I'll probably get an email as soon as this presentation finishes. So the goal is here to simply provide an overview and hopefully spark some discussions, not to provide a complete and comprehensive overview. The goal is to get those discussions, a broader understanding of the sort of things we can offer, and hopefully result in more research and development to help facilitate that technology commercialization. So from the highest level, how do we sort of generally move through this in a sort of very technology-focused context? You know, we all have a great idea, we scribble it on a napkin, and then maybe we move to building a numerical model of it, and building a first prototype, look at what the hydrodynamics hull might be, and then maybe we build a device, but maybe we don't build the full power takeoff for the full engine in, and then we sort of slowly scale up. We try one, and hopefully at the end of it we sort of have our big ship. So I couldn't find a WEC or a tidal energy schematic that sort of mimic this. So excuse the vessels, but I think this is sort of generally how we think technologies are going to innovate and how they're going to grow. But in reality, it's a little messier. It's a little more iterative. As a product or an idea develops, we sort of go to that next stage. Then we need to reassess our assumptions, and as we learn more, we sort of go back to the beginning again, and then we sort of get a little bit further along and we go back. And this is necessary. And at each of these iterations, we need new testing facilities. We need new expertise. We need new people to enter the arena to help us move forward. So that's where all the white lines are. The red lines trying to say also a lot of this expertise in testing is so hopefully to stop us going from a napkin idea to a full-scale device, but to sort of mitigate some of those risks, so we can start to work through a rigorous process to maximize value. So that's sort of where we're coming from in this presentation. So where do we see Pmac playing a role here? When we take these concepts to projects and hopefully to projects in the future, where do we sort of see ourselves plugging in? So again, we work with players and developers across the whole marine energy space. We help develop models, whether they be numerical or small physical ones. We help test those folks, and we help them start to understand how do those technologies work. Then we may go and look at power takeoffs. We may go and look at specific integration challenges. We may do some component testing. Then we may move to some of our more high-profile test facilities like the Tanah River or the Russell Davis Light, or as Dan's going to talk about, PacWave. And then hopefully move through this process to get products and projects out the far end. And those are sort of, often we highlight these facilities that we have, but I want to put a big wrapper around that whole thing and talk about expertise. Because at every stage of this process, we really need to bring expert knowledge and expertise to bear. So whether we're doing WEXIM or Proteus DS modeling, or we're throwing Swift buoys out to look at extreme conditions, or Dr. Sarah Henkel in the lower right here doing benthic ecology measurements out of the Hatfield Marine Science Center. These are all necessary components in order to go from this concept to a successful project. So, and I want to reiterate though, while my talk here will focus on things that we do at Pmac, a lot of the expertise and the capabilities here can be utilized anywhere. whether it's at PNNL's test sites or NREL's or Sandia's, or across the country at the new AMEC test sites. We really hope that some of the knowledge and expertise can be broadly used across the sector. To sort of break this down a little, where do we start? So again, we generally go from our napkin drawing and we move to our computer model. And we've got a huge amount of people, different models we can bring to bear on this problem. I'm not going to get into all the details because, you know, then my 10-minute talk will take 2 hours, but just to say there's a lot of capability and expertise there. But in terms of physical testing facilities that often get the sort of high level attention, you know, across the center, we've got a number of them, whether you're looking to test floating wave energy converters or seafloor mounted wave energy converters, or you're looking at tidal devices. So the Hinsdale, the OH Hinsdale Wave Resource Laboratory on the left here was established in 1972, and it's a state-of-the-art center conducting both applied and fundamental research. There are 2 big facilities within Hinsdale, both the large wave flume and the directional wave basin, to allow marine energy technology developers to subject their scaled devices to waves, extreme seas, storm surge, and a host of other environmental factors. But there's a number of different things on the TEMR website. I'm not going to get into the specifics of each one, but you know, we can go from deep conditions with big waves to directional waves in the other basin and allow you to test really what you're looking for. There's actually a group of students who just finished a tour of the OH Hinsdale Wave Research Laboratory this morning, where Acilla Power, funded by the TEMR program, is testing an array of 7 Triton devices. And these sorts of opportunities to get students to come and integrate or be aware of testing that's occurring and where technology developers are, really create this new level of excitement for future students and are sort of fundamental to that workforce development portion we were talking about in the last section. So it's really great to get students in, and TEMR has been fantastic for supporting tests so we can bring people in. On the UW side, and as we move to more maybe some tidal devices, you know, there's the Alice Tyler flume, which allows us to look at free surface open channel flows, where we can control water speeds, water depth, temperature. So we have sort of independent control of Reynolds and Froude numbers. The glass walls allow us to do sort of laser Doppler velocimetry and particle image velocimetry, so which is really necessary to get into some of the nuances of these tidal devices. We've also got the WASRF lab, the Washington Air Sea Interaction Facility, where we can start to look, we can put winds, waves, currents all in at the same time and start to see how do those affect devices. But these are at the small scale. This is where we start to reassess and we start to move that project forward. Where's my mouse? My apologies, I can't move my slide deck forward. There we go. But then as we sort of get through those small scale tests, we're like, okay, we start to understand the hydrodynamics, we start to get some of these. Then we need to start to look at individual components and how do they integrate with the greater, whether it's the utility grid or a remote community or an oceanographic buoy or an underwater vehicle. How do these systems start to work together? So under the Pmac umbrella, we've got 2 major facilities that we do here, the Wallace Energy Systems and Renewables Facility at OSU, and the Power Systems Integration Lab at ASEP, the Alaska Fairbanks State. So we serve as one of the highest power university-based energy system labs in the country with about a 750 kilowatt capacity. There's a number of really great linear test beds, batteries, storage technologies, hardware in the loop hardware, which really allows that team to move this component integration testing, move forward. And they also have a lot of ability in converter modeling, control development, power takeoff design, so you can start to see the connection between your components and that testing that happened in the first stage of the modeling. At ASEP, this facility operates at the same scale as a village power system. So if you're looking to power a remote community or get your device in, this is a sort of scale that you're going to be working at, and you can do it in a controlled environment. So before you go out to the site and you have that sort of potentially chaotic field testing sort of setup, you can go to the Power Systems Lab and really in a controlled and flexible setting, you can start to understand, you know, how do island and microgrids work? How do your distributed generation scenarios sort of play out? So incredible facility. And once we've done all those sorts of testing, we need to scale up. We need to get to open water. And they're sort of size up rather than scale up, because as we all know, scale's a different term, but we need to size up. And again, depending on what your technology is, maybe you want to go test a riverine technology at the Tanana River hydrokinetic test site up in Alaska, where you can start to look at the impact of debris. Can you look at the impact of frazzle ice, but in a real world, full scale setting? You know, up at the Tanana River site, they've just finished testing their new energy 5 kilowatt vertical axis turbine, which is now a new asset that anyone can use if you're looking at different control mechanisms and things. I know Garrett Staines in the Triton project, which we just heard about, has been up there last summer and testing it out. So again, that great interaction between sort of lab industry and the Pmac test sites. The Russell Davis Light at UW is a new versatile and efficient platform to test turbines, larger turbines compared to the Harris facility, but not full scale, you know, open ocean turbines. Maximum diameter is probably about 1.5 meters, and we can go up to about 5 knots. So great, again, a flexible, quick to deploy, quick to recover test site to start to understand different sensors, different turbines, that sort of thing. Then we've got PacWave. I'm not going to get into PacWave. I'm going to leave that to Dan to dig into, but this is the fully open ocean test site, pre-permitted to look at WEX, components, installation, ocean operations, and a whole slew of other activities. Now, those are all about test facilities, and wrapping around that is really this expertise or the testing capabilities. And again, this is this exercise in exclusion. I'm not going to talk about any of the people who do it, but rather to overview whether you're looking at technical, environmental, or social aspects of this problem. We do have a fantastic set of faculty members that we sort of tap and ask to help support. So I would suggest either looking at the pmac.us website to look through folks, or email us directly at research@Pmac, testing@Pmac. And if none of those work, please email me directly if you need any of these sorts of team to support you, whether it's maritime robotics or energy policy or marine mammals and benthic ecosystems. We have folks who can help support and bring that expertise to bear. And then I think it's finally important, as we sort of look over all these things, that it's just as important that while we have great facilities and great expertise, it's equally important that we all keep standards and process in mind. And under PMEC, we do have a number of faculty members engaged in the IEC standard, not just to make sure it gets followed, but also to make sure we continue to improve and develop the standards so that as we learn new things, they are sort of integrated and help support the industry move forward. So I'm gonna say thanks again to Matt and the POET team for giving us this opportunity, and looking forward to questions.
Thanks, Bryson. Start dropping your questions into the chat if anyone has any. We'll be addressing those towards the end of the presentation, but thanks again, Bryson, for that. Great segue into PacWave presentation. Dan, we look forward to hearing from you. The floor is yours. The screen is yours.
Great, thanks, Matt. And again, thanks for putting together the conference again this year. It's going to be nice when we can do it all again in person, but for now we're virtual, and it's great to be back with a group of people who we've met and worked with so much in the past. So
hey, Dan, you're in, just real quick, you're in presentation mode there. I'm gonna go hit the display settings at the top.
There we go. Is that better?
Yep.
Okay, perfect.
Thanks, Dan.
For some reason, it flicked around on my 2 monitors. Perfect, thank you very much, Matt. Okay, so really what I'm going to give you today is a little bit of an update on PacWave South. I'm going to talk a little bit about PacWave in general, but my focus will be on our PacWave South site. For those that don't know, PacWave is part of Oregon State University, and as Bryson was talking about, we are developing and have developed and operate offshore open ocean wave energy test sites. We have 2 sites located off the coast of Newport, Oregon. This is Newport here. We have PacWave North. PacWave North is not grid connected. It's for standalone testing, generally of smaller scale devices, prototypes, and powering the blue economy type technologies. And then our primary site is PacWave South. PacWave South is currently in development And once operational, will be pre-permitted, we'll be able to offer accreditation. And the critical thing, the critical difference between PacWave North and PacWave South is PacWave South is grid connected. I'm going to focus on PacWave South for the rest of this slide deck. Many of you have already heard about PacWave, so I'm going to sort of give you a very, very high level overview and then an update. But as I said, the site's located off Newport. It's about 7 miles offshore in about 260 feet of water. The site itself is 2 square nautical miles, and the idea is that that will be divided up into 4 different test berths, so we can have independent testing by developers in 4 different berths. And each of those berths is connected to shore with a dedicated subsea cable, a power and data cable, rated up to 5 megawatts. PacWave South is licensed for overall total power output of up to 20 megawatts and to test up to 20 devices at any one time. The cables coming from the site are going to be buried under the seafloor until they get to the nearshore area where they're going to enter buried conduits. And then the cable landing site is at Driftwood Beach State Recreation Site, Driftwood State Park in Seal Rock in Oregon. And then just down the road from it, about a quarter of a mile away, we have what's called our Utility Connection and Monitoring Facility, or Ucmf. And this is really the nerve center of PacWave South. There'll be test bays for developers, there'll be control rooms for developers to use, power conditioning equipment, and ultimately the power that's generated from PacWave South will go through the Ucmf and then onto the Central Lincoln People's Utility District system. So that's the grid connection. Funding for PacWave primarily through the US Department of Energy, significant funding from the state of Oregon, from Oregon State University, also some funding from some trusts and foundations and some other supporters. Now, we've been talking about PacWave. You've heard about PacWave at previous conferences and other venues. And this is the timeline for the development of PacWave. And as you can see, it's been going on a long time. We started back in 2011, 2012 with the preliminary design and site selection, including a community site selection process that ended up with Newport as the base of operations for PacWave. And in 2013, we moved into the permitting phase, which included preliminary design and preliminary engineering for the site. And as you can see, this was a pretty protracted process. A lot of engagement with stakeholders, consultants, federal agencies, state agencies. Part of the reasoning why this permitting took a significant length of time, partly because we're a test site, so it's very difficult to define what we're going to have out there at any time, and that's complicated for the permitting. And also, similar to what Nikki was talking about just now, we are pre-permitted for the majority of types of wave energy converters. So and that doesn't mean we can just go out and do anything, but the majority of types of WECs will not require additional federal permitting to come and test at PacWave. And that was an unusual requirement in our permitting and took a long time to hammer out, but we feel that's definitely going to be important for developers. So at the beginning of this year, in February, we received our lease from the Bureau of Ocean Energy Management. And then at the very beginning of March, we received the final piece of permitting, which was our Federal Energy Regulatory Commission license. And that was basically the end of many years of permitting process. And that opened the door for the start of construction. So after many years of talking about PacWave as a plan and a concept, we are now in the construction phase. Construction of the site is underway. And as you can see here, we still have a couple of years of construction to go before we're operational for grid connected testing in 2024. I just want to talk a little bit about the construction where we are and what's going to be happening. So we have a couple of early phases of construction. This is what's underway at the moment. At our cable landing site at Driftwood, there's a major construction for our terrestrial infrastructure going on, the horizontal directional bores. And I'll get into that slightly more in a minute. That's going on at the moment, started on June 1, will go through until early in next year, spring of next year. At the same time, we have initial work starting on our utility connection and monitoring facility. What we're doing at the moment is site preparation, upgrading utilities, roadways, grading the site in preparation for the actual construction of the site. The construction of the facility itself will likely happen in either 2022 or 2023. The real big piece of the project scheduled for 2023 is the subsea cable installation. Subsea cable manufacturing will probably be happening next year in preparation for a 2023 install, which will lead us, as I said before, to test operations for grid connected testing in 2024. Other testing can happen in advance of that, but obviously grid connected testing will happen once we have all the cables in place. So to talk a little bit about, in more detail, about the terrestrial infrastructure work that's going on. As I said, we're based at Driftwood State Park, started on June 1st. And the major undertaking at the moment is these offshore bores that we are doing. These are horizontally directionally drilled bores, each of them going out approximately a mile from shore. The longest bore, the north bore, is 5,308 feet. These bores get lined with steel casing, steel conduit, which will be what's left in place, and ultimately that's through which what we're going to pull the subsea cables when they're installed in 2023. So we're currently working on these bores. We have the conduits installed on the north bore HDD1 and the south bore HDD4, and we're currently drilling at the moment on HDD2 and HDD3. When those bores are all complete later this year, maybe late next month, we will switch to doing a terrestrial bore between Driftwood and the Ucmf facility. And when that's complete, we will rebuild the parking lot at Driftwood and build an underground splice vault where the subsea cables will come in and transition to the terrestrial cables. So this is a profile of the horizontal directional drill bore plan that's going on at the moment. These are long bores. A mile long bore offshore is a pretty extreme bore to do. What we have here is the parking lot at Driftwood, and the bores go down underneath the beach and the nearshore area and down into this competent rock, this Nye mudstone that they drill through for most of the bore path offshore. At times are about 140, 150 feet below the seafloor until they curve up and break out about a mile offshore. Once they've done the bore, then we pull the drill string back and then install all the conduit. So this is from a couple of months ago. This is Driftwood State Park, the parking lot, Driftwood Beach here. There's a pathway down to the beach. We've maintained pedestrian access, even though we've taken over the whole parking lot for the duration of the construction. What you can see here is two very large drill rigs, horizontal directional drill rigs in operation. We have two running at a time. In this picture, we have HDD4 heading out this way and HDD1 heading out this way. At the start location, they're located pretty close together. You can see here the separation between HDD1 and HDD2, which is about here, is approximately 8 feet. And the separation between HDD4 and HDD3 are about the same. But the bore paths are diverging, and offshore, their breakout points are about 150 feet apart. This is a terrestrial view of the drilling operations. This was taken a couple of weeks ago. This is you can just see this piece down here. This is the capped off HDD1. This is drilling operations on HDD2. And this is installing the conduit on HDD4. And these bottom pictures are the pictures of this conduit. It basically looks like slightly rusty pipe, but that's actually a very expensive anti-corrosion coating that we have both on the outside of the conduit and the inside of the conduit. And because this coating it's critical that this coating is protected, it's actually been quite an interesting challenge for the company on the installation to ensure that we can screw all these sections of conduit together without damaging that coating before it's installed. So as I said, HDD1 and HDD4 are complete, and the other two bores, one of them we're at about 2,400 feet out, and the final bore is at about 1,500 feet as of yesterday. As I mentioned, once we're done with those bores, we're going to move to the terrestrial bore. This is driftwood here and our Ucmf property. This is a shallower and shorter bore. It's 2,300 feet underneath the wetland system, underneath the highway, and to the property. Maximum depth is about 45 feet. Challenging in other ways because of sensitivity of wetland above it. So actually the drillers are incorporating an intercept method, so they'll be drilling one bore drilling from one end and one bore drilling from the other end and intercepting underneath the highway here. So the accuracy of their drilling is pretty remarkable. The reason for that bore is to get the power from driftwood to our utility connection and monitoring facility. And this is our architect's rendering of the Ucmf facility. This was done by HG Architects, who are the company that we hired based out of Coos Bay. And as I said before, this will probably be constructed in 2022 or 2023. The site itself was a Christmas tree farm, so we're focused now on clearing the site, grading. This is actually the location of the facility itself, and improving roadways and putting in all the utilities in preparation for ultimately the construction of the site, the installation of the cables in 2023, and the start of operations in 2024. So that's where we are at the moment. It's exciting to actually be underway and in that construction phase. Plenty more information about PacWave and about the construction at pacwavenergy.org. And with that, I will pass it back to Matt. Thanks.
Cool, thanks, Dan. Fantastic to see the progress. I'll start with a quick question straight to you. I know you gave myself and the POET team a great tour of the drill site. Obviously, we have very high level access, VIP access due to, I'm just kidding. Is there opportunities for the public to come and see what's going on there? Is there any upcoming tours or meetups, or can they reach out to you if they're interested?
If people are interested, they can reach out to me. We did have an open house a month or two ago, which was really aimed at providing some access to the locals, because they've lost their state park and there's a lot of noise and disruption going on. We don't have any set tours at the moment because, as you can attest, Matt, having been there, it's a pretty active construction site, a lot of equipment moving around and a lot of people on site working. But if people are interested in a tour, they can reach out to me. I'm on site pretty much the whole time and quite happy to show people around.
Yeah, you got your office likely has the best view out of anyone I've seen lately. Go in one direction at least. Funny story, I was walking down the street the other day and I saw one of my neighbors having a new water line installed to their house, and they were doing some directional drilling. So I actually went up to the guys and I gave them some tips from what I learned on my tour at PacWave. They didn't care. Let's jump into the rest of the questions, and thanks. Thank you, Jason, for submitting, as well as anyone else who has questions. Feel free to drop them in the chat. We'll make sure to get to them. Bryson, I believe you can see Rick's question in the Q&A there. I think that's mostly addressed at you. And if you can't, let me know, I'll read it to you. But otherwise, Rick, I know you're out there, and I feel like you need the opportunity to say go Beavs. So if you want to type that anywhere into the chat, it wouldn't be an OREC conference without it. So Bryson, hand it over to you.
Thanks, Rick, and for the question. So Rick's question, just for folks if they can't read it, was around looking at the predictability and forecastability of marine energy resources against terrestrial wind and solar. And there has been some really great work, both at a number of the universities and the labs around this and trying to quantify those benefits. So I know Nikki referenced some of the work that they're doing, their team's doing up at PNNL. I know NREL's doing some really great work, and we've done some work here at OSU. So I think there is a lot of great numerical work that's ongoing. It has pointed to the benefits. You know, you get a 4 to 10 times, depending on what metric you use, sort of improvement in the need for spinning reserves and other sort of in utility scale backup reliability sort of aspects that are coming online, and that's great, and that's there. I would say what we need now in order to really make those numbers hard and fast is we need more devices in the water, and we need more data from devices. A lot of that right now is based on sort of upscaled numerical models, which have been validated against tank tests, which is all really great, but we need devices in the water now to make sure that those numbers are correct, so we can go and market those benefits. But I think it's a huge opportunity for the sector. I think it will have value as the whole energy system transitions, which is a lot of what the discussions were yesterday. But we need to get devices and hardware in the water to quantify those exact numbers.
Thanks, Bryson. I'm going to just roll through some questions here. And this question might be relevant to more than just Nikki, but so Jason asked, how long does it take to get through all the contracting for deploying a device at PNNL? Any permits the developer needs to get on their own? Does PNNL help with that? I think this question applies to Dan and potentially Bryson as well, and really to any open water testing. It's not, you know, those are things that need to be considered in both the timeline and the budgets of an open water test. So Nikki, I'll let you briefly describe the authorizations that PNNL currently has. No need to get into the weeds as we've done many times before, but and then Dan, if you want to talk briefly about permitting at the PacWave sites, that would be great too.
Well, I think my briefest of responses would be it depends. But you know, I guess here there's two parts. So one was the contracting. Teamer is a great way for developers to come to labs and other facilities, right? Because we typically don't have an easy contracting mechanism otherwise. There are some programs. So think about Teamer. I think, you know, the length of time, Teamer's kind of done a lot of work to make sure that that's relatively streamlined. So, you know, we're talking about months really between, you know, when projects are given the green light to go and, you know, test plans are approved so they can get going. In terms of the, you know, the in-water activities, ideally what we like to do is make sure that before we entertain anybody coming in the door, that what they want to do actually fits within the envelope. And if it fits, then there really isn't any work to be done. Nobody has to do any heavy lifting. If it doesn't fit and, you know, this is deemed a really great project, you know, then we kind of actually have to start at square one in terms of permitting and authorizations. And there's steps from there, but then you're looking at, you know, 6 months plus before you could get in the water.
Yeah, perfect. Thanks for the Teamer shout out there too. We work a lot in the background to really assure that efficient and relatively straightforward access to the facilities. And that's going to apply to the open water facilities too. That's the goal. That's why it's taken us a significant amount of time to offer open water testing, because there's a lot of complexities that are required to get to that point, and working with the facilities to identify those and document potential effects and things like that. So Dan, quick briefing on permitting, what pre-approved means at PacWave. That would be great.
Yeah, and I think Nikki summarized it. It really depends. For PacWave South, we're pre-permitted for various types of wave energy converters. You know, because we're still in construction and we haven't actually done this, you know, it's going to be interesting the first time we go through it, because, you know, one of the types we have that's pre-permitted is a point absorber, but a point absorber can be a lot of different things. And, you know, so based on the permitting, a point absorber should be pre-permitted. If it's not what the agency's are expecting, then that may lead to some extra consultation, maybe not formal consultation that needs to happen. But if you clearly fit within the borders of what's predefined as pre-permitted, it's pretty straightforward to come and test at PacWave. Contracting, again, isn't something that we've gone through yet. I'm sure it will get more streamlined as we do it more often. PacWave North is not pre-permitted. Anyone testing at PacWave North does have to get permits. It's in state waters, so it's a little simpler. But we estimate 6 to 9 months for someone coming in to test at PacWave North to get permits. And again, it very much depends on what you're looking to do. If it's something that the agencies are familiar with and comfortable with, it will be a lot more streamlined. If it's something unusual and that they're not familiar with, it'll just take longer to have those discussions.
Thanks, Dan. As we say a lot in Teamer, and I think the industry at large, consult early with anyone and everyone to help, with the design. It could help with the design of the device that you're planning to bring to the site as well. So you're the expert at PacWave. Nikki's the expert. There's lots of experts in addition to Nikki at PNNL. Never hurts to have those conversations far in advance and to start thinking about what your project might look like and the limitations that may be there in front of that. Dan, that kind of leads me to another question, something that comes up a lot. Who can test at PacWave? Like, what do you have to prove of your technology to be able to deploy it at PacWave in the future? Are you looking for full-scale devices, things that have been tested at WETS, for example? What kind of specific testing regimes should things have been through prior to really thinking that you're going to be testing at PacWave?
There's no hard and fast rules on it. One of the things we are looking at is developers who have gone through WETS for the utility scale testing of devices. PacWave South especially is thought of on the utility scale WETS more on the high-end TRL, just pre-commercialization stage. However, there's lots of other opportunities for testing at PacWave, whether it's component testing, whether it's instrumentation testing, there's all sorts of things that there are possibilities, and those are all open. They may not fall under our pre-permitting, but that doesn't mean that those things can't be tested at PacWave. What we do want to see is some sort of testing to ensure that what we're going to have is something that's going to be reliable and safe, and we're not going to end up with some sort of disaster at the site, which is not what we need for starting up a wave energy test facility. So we will need sort of documentation, proof that these devices or systems being tested are liable to be able to survive what is a really pretty extreme wave resource out off the Oregon coast.
Do you mind if I jump in there, Matt?
Please.
Yeah, no, I just sort of building on what Dan was saying there. I think a lot of our general focus is often on what is the WEC, what does it look like, how do we get it deployed? I think just reiterating that all sort of those bulk of system things should be tested too. So whether it's connectors, whether it's anchors, whether it's mooring lines, whether it's interconnections, whether it's acoustics, all of those are necessary measurements for us to drive forward as a sector. And PacWave gives us that site to test those where we do have a really good baseline of everything else. So it kind of also relates to the question there, how does Pmac relate to PacWave? PacWave is an incredible testing facility, and it's going to be there for everyone to use. And if you're looking to just come test your commercial device, you can just go test at PacWave. There's no need to engage with Pmac. But if you do have R&D questions, you're like, well, I have a new anchoring system. I'm not quite sure what the geotech conditions look like. How's that going to work? Then it's like, okay, well, let's bring the expertise within Pmac broadly to bear on that problem. And we can bring you expertise that you may not have within your company, because you're focused on your core IP of developing your PTO or your body or whatever it might be. There's no need for that to be hired at every company. Let's get that out. Let's make it open source so that it can help benefit the whole sector. So the next company, the next permit that needs to be got, whether we go back to that permitting question, we have a lot more data to reinforce those. So hopefully permits can be issued quicker because we have more data.
Thanks. Bryson, while you're on the screen there, let's go to Sam's question there. Could you expand a little bit on international competitiveness? She thinks it was on a slide near the end of your slide deck.
I didn't think people actually read all of the words on that slide. So
And the
apologies. So that's a great one. And there's a role here. I would say we should almost change that to international collaboration. But some countries you collaborate really well with, and other countries you compete against a little bit more. But I think a lot of that is working with partners. Henry was on the last call about trying to understand what are best practices, what's worked there. If you've done a lot of testing on a certain component or a new forecasting algorithm or something, let us look at that. Let's try and do it here. But within all that collaboration, when you get a test site like Pmac and you get a test site like PacWave, let's be honest, we're all going to be hunting for the same companies to come and test, and looking at what do we offer to the marketplace, and trying to diversify what we do. So we're more supportive. We can make sure these things are, these projects are self-sustaining and they do move the sector forward. So there is always this collaboration between the two. So that's really kind of where we were getting at. And I think it's just looking at where we are, what can we offer, how do we help support each other, and how do we maintain, and how do we help maintain some leadership?
What do you think about marine solar technologies? I feel like we've spoken about this before. A question came in from one of the attendees.
Yeah.
Opportunity for testing. Yeah. Is that something that would fall under PMEC's umbrella? It's not a traditional marine energy. It's going to be floating at sea. I know we have these conversations a lot of especially within Teamer, of what marine energy really means. And, unfortunately, there's walls between what we formerly call hydrokinetics and what we talked about with wind. But where does solar fall in that spectrum?
So I'll let everyone, maybe I'll jump in because I'm unmuted, and then let everyone else jump in. From PMEC's perspective, we think of marine energy as energy from the marine environment. Yes, we focus a lot on wave and tidal, but we're doing a lot more work in offshore wind these days. Floating solar is of interest to a lot of people. From a research perspective, wave and tidal is really hard. So a lot of those skills, models, processes, techniques we use are easy to apply to floating solar. And if there is an opportunity to test those out, and we're going to move towards decarbonization, and I don't see any, at least from PMEC's perspective, those are all fair game, and we're really interested in helping support all of them.
Nikki, I know you guys get a few sunny days up there in Squim. Is that something that would fall under testing opportunities in the Bay?
We are the blue hole, right? That's the secret of the peninsula. We don't get a lot of rain. Yeah, I think certainly it's on the table and it could be a consideration. I think Bryson, covered the topic well. I think that, we have other programs that are allowing us to kind of expand beyond the envelope of, what we define as marine energy, at least in terms of Teamer. So yeah, I think that there's some additional opportunities.
Cool, thanks. And Dan, if you wanted to tap into that for a potential PacWave solar, or is that just let's focus on the current demand for wave energy and get there when we feel the need?
I think if people wanted to test solar out of PacWave, it wouldn't be a very difficult sell to the agencies. They would be looking at it from an environmental effects point of view, and having a device floating that's got solar panels out in the ocean is not going to be any different really from having a WEC out there. It's not currently under our permitting, but even if something's not under our permitting, it just means we have to have more discussions with the agencies.
Not a whole lot of moving parts. I don't want to speak for any agencies, but in theory, that would potentially be a little easier from my perspective. To question for Marcus, and I think Dan, you're on my screen, so I'll point it back at you. Does PacWave have good analysis of weather windows and statistics suitable for maintenance? Because everyone's going to be having to get out to their devices fairly regularly. How would you purvey that information to somebody? Is it available?
Well, I'll pass it over to Bryson. Bryson and his team have been doing a lot of analysis of that. So I will pass it over to Bryson.
Sure. I can answer somewhat. I live in Oregon myself. It's cold and windy from December through June, and then we get great weather. But Bryson, you probably have more statistics on that.
No, for sure. No, and it's a great question. So I'm going to figure out how I can drop in a link. So there are a couple of documents that I'm going to send to the group One is the PacWave resource assessment, which looks at weather windows. Now, we looked at weather windows from a fairly small perspective, where we just looked at wave conditions and wave periods that mitigate the impact to vessels to allow them to do marine operations. And it shows, generally what time of year you get those windows, how frequent you get a 2-day, 3-day, 4-day window, that sort of thing. So I'll put that link in. There is an effort to expand upon that, to look at the combined effects of winds and currents on top of that, just so we know we may have a small wave day, but it may be really windy, which might not be ideal. So I'll figure out where to drop those links to a couple documents that should help. But we're always open to ideas. If we've misrepresented what the conditions should be, it's easy enough for us to rerun those sort of analysis to get them out. Again, the goal here is to help facilitate the growth. So glad to hear the question and keen to help out.
Yeah, hey Bryson, send that info to the POET team and we'll get it posted on the Whova site, because I think once this session's over, folks won't have access to the chat here. So it'll end up somewhere in the community tab of the platform there on Whova. Nikki, I'll jump that question over to you. I know that you're in a bit more of a secluded area, so I think typically annual operations are not as big of an issue in Sequim Bay, right?
Yeah, that's true. So I think one of the reasons that we chose another test site in addition to Sequim Bay is that Sequim Bay it's protected, which is nice, which means that, yeah, we can get out in the winter months. We don't have as many days where we're excluded from in-water work. But that Clallam Bay maybe represented a different site where conditions were a little bit different, more open, lots more waves. So we are collecting the data. I mentioned we have the wave buoy deployed there now, so we're collecting those data. And also, I didn't mention this, on the pier, we have worked over the last year to install various sensors to where we could, provide live stream data available to anybody. So those include things like tide gauge, and I think there's a weather station on its way, in addition to some other, typical parameters that someone might like to see, temperature, DO, those kinds of things.
Awesome, thank you. I see a question in here, we got a couple minutes left, so I'm gonna address one more maybe in-depth question, and then I see a teamer question I'll answer there at the end. Dan, what's PacWave doing with the electricity? I think you mentioned Lincoln City PUD. Is that power being sold to them? Is it something that has OSU explored potentially selling renewable energy certificates, something along those lines, to market that power separately? Is that something you can answer for us?
It's an ongoing discussion. We're having various discussions with Central Lincoln PUD and BPA. I'm not an expert on this piece, but I know it's something that's still under discussion without any resolution as yet.
Cool. And then one last question, kind of for the whole group, outside of Teamer, because I think Teamer is a great way for the industry, for researchers and developers to access these testing facilities and infrastructure that we've talked about today, as well as a whole host more that wasn't mentioned in this panel. Are you open for business? Is this someone, if someone had the funding, could they pay PNNL to test a device? Could they pay OSU to deploy at PacWave, or to get assistance from one of the Pmec facilities? Or, Teamer's a great opportunity. We have kind of defined pathways for that, but how can folks engage with you, for project specific type work?
Who do you want to go first?
Go for it, Nikki.
So you're meaning outside of Teamer, yes?
Let's say outside of Teamer, because I think Teamer we understand is an opportunity, but maybe something doesn't fit within Teamer. Yeah,
for sure. I say, reach out. I think that, like I said, there are other opportunities and programs outside of Teamer. And so I think, it just depends on the scope and scale of, what it is that someone might be looking for. And then, with the panelists that we have here, I think there was a question earlier about, how do we all collaborate, or do we all collaborate? And I think the answer is yes. So certainly I think that we can work across our network to make sure that, testing can happen one way or another.
Yeah, Bryson, do you want to just add to that?
I just want to. I was putting a link in. I'm just going to confirm the question was outside of Teamer. How can we get support to access these test facilities? Is that correct?
Yeah.
So I'm not sure if anyone's aware, there's a big FOA on the street to test devices at PacWave, so I would suggest that's a great opportunity, because not only would you get support to just test it, but you get support to build it. So I think that's a fantastic way. And I think it's keeping on those, it's utilizing all the tools in the tool chest. Look at your SBIRs, look at all of those different funding programs. And it's something we're constantly working on with PacWave and the whole sector at large to try and figure out, how do we make this match? How do we make the money move the furthest so we get people testing? And again, we get big tests like at PacWave, but it's also, we need sort of rapid, easy to do tests where you can go in and out and learn things lots. And that's where maybe some of those smaller scale tests, whether it's the RV Light or going out to the Tana River or out to Swim Bay, where you can do sort of smaller component style tests. I think we mustn't lose sight of making sure we test all those on the road to a bigger test out of PacWave.
Yeah, great. Thanks, Bryson. There's one last question about RFTS. I believe it'll be 5 when that next opportunity will close. You can apply now. Currently, the applications are open. We leave the application opportunity open anytime. We'll be closing that mid-December, right before the holidays, to ensure that our technical board gets no rest or vacation when we're just kidding. But no, every 3 months. So we just closed mid-September. We'll be shooting for mid-December, and then following on, what's that make it? March or February, if I'm doing the math right. But the goal is to provide those regular opportunities. Wait till you're ready to apply. There's no need to rush. There's always more coming down the line. It really helps to get in there and talk with your facilities, define the goals of your project and how that facility can support you, and then put together a really strong application based on that. That's the reason we're offering these so often. We like to see really well thought out and not rushed opportunities. So hope that answers your teamer question. With that, I'm going to wrap this up and thank Nikki and Dan and Bryson so much for their participation and expertise and knowledge that they've provided us today. Hope everyone's doing well. I'll be back this afternoon for a Steel in the Water project panel. We're really excited to talk about the technologies that are going to be deploying actual things in the ocean here soon. So tune back in this afternoon. I think Jason, you're going to take us away.
Sure, just putting an endpoint on it here. Matt, thank you so much for that. And Nikki, Bryson, Dan, great to hear the progress on all these fronts. Exciting times for the marine renewable sector, and looking forward to what the next few years are going to bring us. With that, it completes the morning sessions for Ocean Renewable Energy Conference. We're going to take a break now. It's 11:45. We're going to break until 1 o'clock Pacific time. At that time, we'll have a panel on sort of update from Washington, D.C. with Paul Gay, Damian Kunko, and Tim Ramsey from the Department of Energy. So enjoy your lunch. Join us back at 1 o'clock, and we look forward to seeing you then. Thank you very much.